take a class, and teachers learn a lot the first time they teach a class. So let's go for today. Okay, first off, I decided I was going to say this, and then last night when I was thinking about it, I decided that wasn't a good idea. What is the hyperbolic function? Well, you remember back from the good old days of trigonometry, if you remember circular trig. Circular trig was all based on what particular circle? The unit circle, our old friend, the unit circle. In the unit circle, of course, the equation for that x squared plus y squared is equal to 1. Of course, you know that's a circle with a radius of 1. And then you probably learned more things about it than you ever dreamed of or wished of. But as I kind of mentioned in side topics once in a while, there are more geometries than just Euclidean. You learned Euclid's rules. You learned Euclid's axioms. What if instead of basing it on a circle, we based it on a hyperbola? So what's a hyperbola? So what if we change that x squared to a negative? Well, what's a hyperbola look like? So we would have that y is equal to the square root of 1 plus x squared. So of course, you add x squared to both sides, take square root, or equally, it could have been the negative of that. If you remember from pre-calc solving all those circle problems, it always ends up with a minus x squared or a minus 2x squared or minus like the quantity x minus 4 squared. With a hyperbola, it ends up with a positive underneath that square root instead of a negative. Which I hate to use the word, it's kind of like a reflection of the circle, but it's kind of like a reflection through the circle. So what if we instead looked at trig through the eyes of the hyperbola instead of a circle? So instead of having a circular relationship to the trig functions, what if we had a hyperbolic relationship of the trig functions? Which we could. And here's the good news. For those of you that decide to major in math, you'll take a geometry class. And that geometry class will say, well, you learned Euclidean geometry. Let's throw that out. Let's instead define, morning, Gabby. Let's instead of defining parallel lines of lines that never intersect to be parallel lines that have, parallel lines is any two lines where alternate interior angles are equal. Well, we know that. We learned that in geometry. If you have two lines that intersect, alternate interior angles are equal. But there are also different kinds of lines that have alternate interior angles that are equal. Like these would be parallel lines because the alternate interior angles are equal even though they intersect. Well, what if we define parallel lines are where corresponding angles intersect? Well, then we get something like this to be parallel lines. So we gave you like the intro course to geometry, but there are other geometries as well as Euclid's. Hyperbolic geometry is another one of those. That's what sine, cosine, tangent, hyperbolic all look at the lens through. Now, what do you really have to know? You have to have those definitions memorized of what the derivatives are. I will give you a brief introduction because there are some differences in the properties of like sine and cosine with hyperbolic functions that aren't true for Euclidean or circular trigonometry. But again, what do we have to get out of today? You have to be able to find the derivative. But if you're in a dark alley and somebody asks what it is, it's related to a hyperbola instead of a circle. 20 years, do I expect you to be able to explain this to somebody? No, because I had to look it up myself. So luckily I had 3 hours last night to English teachers were talking and I had plenty of time to want to do something else. So let's take a look at identities. Okay, well, let's go back to our friend circular trig. Okay, we know that sine squared x plus cosine squared x is equal to what? 1. Yep, that's the most basic identity they have. Well, in hyperbolic trig, and nope, I need to go backwards real quick. Let's give you some definitions first. The sine hyperbolic, we're talking about that with We're talking about that with hyperbolas. This is defined sine hyperbolic. What's the definition of that? Well, looking at the function, if we actually took the limit as x goes to 0 between those, we'd find that it's e to the x minus e to the negative x all over 2.
Is that just sine?
Sine, that's how you actually spell sine. Now, you could imagine not too challenging to find the derivative of that, because e to the x's derivative is, and negative e to the negative x derivative is going to be, yeah. Okay, cosine hyperbolic. E to the x plus e to the negative x all over 2. And of course, tangent hyperbolic. This one's the same as it was before. That's equal to sine hyperbolic over cosine hyperbolic. And then just like before, secant hyperbolic is equal to 1 over the sine, as long as sine. Oops, that is cosine. That's a cosine. Cosine. Darn projector. Cosecant hyperbolic of x is equal to 1 over sine hyperbolic of x. And cotangent hyperbolic of x is equal to 1 over the tangent hyperbolic of x. Hence the cosine hyperbolic of x over the sine hyperbolic of x. Some people pronounce this like cinch, cosh. I can't remember what the TAM is pronounced. I had a prof in college, so that's what they called it. Cinch, cosh. To differentiate it from sine and cosine. Monahan. Because it's on your AP test. That a fair enough answer? Yeah. Well, and I'm not gonna lie to you. I told you that, and I was like, then I was thinking about it last night. I was like, I feel guilty just saying memorize this, don't know what it is, because then, like, you go to college and you say, oh, my math teacher told me to memorize it, never told me what it was. If I just tell you what this one thing was, then I probably never have told you that, and I didn't really want to give that up. Now, if you are interested in more than that, or you just feel unsatisfied with the amount that I've told you, if you Google it, there are tons of lessons on it. If you major in math in college, you will do a partial unit in geometry on it. And then the fun thing is you'll go and prove all these derivatives in advanced calc. But I'll leave that for those of you that choose to go that far, which should be all of you, but you should all want to be a math major. Math's fun. If nothing else, it's really impressive when you go on a date and say, oh, I'm a math major. Oh, I'm a math and a physics, or I'm an engineering and a math major too. And the first reaction you always get is, hey, can you help me with whatever, insert the name of whatever class that I'm in right now? And you say, yeah, for $45 an hour. And then they look at you like, are we kind of dating? Like, and then you say, oh, that's a discount rate. I gave you 10% off. It's normally 50. So it's a, potentially dating discount. Okay, so then let's look at the identities, which is where I want to go with this. Identities, don't forget with regular, sine squared x plus cosine squared x is equal to 1. Well, what about the hyperbolic? Now, I'm just going to give you the ones that you might need for tonight's homework and you might need for the AP test. There is a page full of them on page 370. I wrote that down, right? 371 of your book. It has all of them. According to the lady from LP, these are the ones that have ever appeared on the AP test, though. But of course, focus. Anything, I guess, is truly fair game. But if you're looking at hyperbolic cosine, cosh of x, cosine hyperbolic minus sine hyperbolic is equal to 1. Keep going. Take the reciprocal of both sides. You get tangent hyperbolic of x squared. And I should have had a squared there. Sorry. Tan hyperbolic squared plus secant hyperbolic squared is equal to 1.
Does squared go before the h or after?
I believe it goes. Let me look that up. Actually goes after the h. It'd be sine hyperbolic squared, not the sine squared hyperbolic. And then cosecant hyperbolic squared x. Actually, cotangent goes first. Cotangent hyperbolic squared of x minus cosecant hyperbolic squared of x is also equal to 1. Now, in all honesty, the only one I have memorized out of these three is the top one. I don't even remember really why I haven't memorized, but probably there were calc problems that I had to use that on, and that's probably the only reason why I have that memorized. Now, does this appear a lot? A lot of the questions that are on the AP test are just straight integral, straight derivative problems, but they have a function inside. So you have to know both the hyperbolic integral or the hyperbolic derivative, and you have to be able to put it into a chain rule. So on this one, all of them that I'm going to give you are the chain rule ones. I'm not going to give you the simple ones first and then go back and rewrite them with all the chain rules, because that would be, well, there's 12 of them, so that would be 24 of them, and that's probably too much to write. So the derivative and integral rules, derivative and integral rules for hyperbolic functions. Okay, it would be really nice if this was equal to what? Straight cosh? E to the x? Any others? Well, usually sine is the what? The derivative of sine is cosine, and it's also positive, and that's the derivative of this. The derivative of sine hyperbolic is cosine hyperbolic u times du dx. Why is it dx on bottom? Because we're taking the derivative with respect to x over here. Now, here's where we get a little bit different. The derivative of regular cosine is, yep, but it's just positive for hyperbolics. The derivative of tan normally is what? Secant squared. Good news. What's the derivative of tan hyperbolic? Secant hyperbolic squared. If I, just like always, if I'm ever going too fast, let me know. Are you guys sick? Like, I've seen 3 of you like barely staying awake. It's gonna be a long week for you all. Debate. We need to start selling Red Bulls. Note to self. Don't. Hey, that's what Widefield sells, and that's all they have to sell to make their money. They just sell Red Bulls in the morning. Health food. The derivative. Let's go opposite. Tangent hyperbolic. What's normally the derivative of cotangent? Okay, here's the good news. All of the secant, cosecant, cotangents are all negative. So it is nice that they're all a family together. The derivative of hyperbolic cotangent or cotangent hyperbolic is negative cosecant hyperbolic squared times du dx. The derivative of secant normally is, okay, it's equal to negative secant hyperbolic, tangent hyperbolic, du dx. And normally the derivative of cosecant is normally the derivative. Yep, but it's negative. Negative cosecant hyperbolic, cotangent hyperbolic, du dx. So if good news is the right word, the only good news is all of the reciprocal trig hyperbolic functions are all negative. All the regulars are positive. The question always is, do I have to have these memorized? Well, in fairness, usually there's 1 or 2 questions, according to Ms. Thurkel on this. If you miss 1 or 2 questions, the good news is you only have to get a 60% to get a 5. So if that strains your brain too much, I guess, you know, it's not going to kill you on the test, but the expectation is, yeah, the formulas aren't on there. So the only thing you have to remember is the negatives and positives are a little bit different. Like the derivative of cosine is negative sine, the derivative of hyperbolic cosine is just hyperbolic sine. Monahan.
Oh, I think it's in for like all the exact same. It's like
I don't make the rules.
maybe don't. But I
Believe me, if teachers could change rules, I think we change the IB test first before we change the AP test.
I would agree with that.
Yeah.
Regular secant isn't usually negative, right?
Regular secant is usually positive, correct?
So it's negative.
Yep. So they're not all that bad. But, you know, what are teachers really good at? Throwing more things on your plate to just see if you can fit any more on there. Okay, go on. And to be honest with you, if you do become a math major, like this is the point when I took advanced calc that I was just about ready to give up on life and become a business major and start to sleep and have fun in college. And then the proofs of these were actually not that bad. And I was like, oh, maybe I can get an A in this class. So they're not as nasty as you'd think, because that e to the x thing, I mean, what's the derivative of e to the x? E to the x, yeah, it just repeats itself. So actually, this is where I started to get hope again. So somebody had a question over there. Yep.
So if you take the derivative of sine hyperbolic u and cosine hyperbolic u, do you just plug in the e to the x plus e to the negative x?
Nope, you can just leave it in terms of hyperbolic.
But then if you're trying to find a value,
If you're trying to find the value from it, you may. Some calculators have it on there. And actually, let me refresh myself. I think it's under the menu, I think. Yep. Okay, take out your calculator real quick. You actually can do this in your calculator. This one's nasty, though. Is it under math, too? I thought it was just under... Andrew, were you the one saying it was under math?
No, it's under catalog.
Yeah, that's the only place I know it is. Does anybody know it's somewhere else? Okay, so this one you got to go to the catalog, which will tell you everything your calculator can do. It's second, the 0 button. And then don't forget, you don't have to scroll down forever. You just have to type in the first letter. That's actually why those green letters are there. Originally, it was so you could text message your friends back before text messaging. But so if you want cosine hyperbolic, go to C, which is the program button. Then you do have to push down for a while. But there is actually both a cosine hyperbolic and a cosine hyperbolic inverse that's on there. So you don't necessarily have to do that from the e to the x function. There is a calculator function for it. Now, I do not think there's cosecant, but of course, cosecant is 1 over the sine, so you'd have to take the reciprocal of both sides first and then plug it in. Ellie, however, looking over questions that were on the AP test, she did not show me one that you actually had to plug it in. They were all in the no calculator section, so you just had to know either how to find the derivative or how to find the integral. Because we did not even talk about that when we were going through this. Because I'm not going to lie to you, I have not done a cosine hyperbolic function since I myself took Calc 2 in advanced calc. So that was over a decade ago. All right, other questions on that? So again, cosecant, secant, cotangent, just remember that's a reciprocal of its corresponding one. So you won't have an option for that on the calculator. You do have to actually take the inverse of it first. Because notice there's no cotangent button on there either. And that's just a simple algebra step. You want more rules or you want to do an example first? Let's do an example. Yeah, let's do an example. Let's say you are in a dark alley and somebody comes up to you and says, oh, how nasty should we make the first one? Let's find this. So find ddx of, let's do this. Sine hyperbolic of 3x squared plus ln x minus 2 cosecant hyperbolic of, how nasty should we make it? Oh, the cosine of x. Aaron, I kid you not. This summer I was taking that class at the academy, and somebody said, okay, well, let's make a really nasty derivative, make it as nasty as we can. And there was a cosine hyperbolic in it. And it took us 4 boards all the way across as a group to do the problem. Well, you get a whole bunch of math nerds together in a room. You're like, hey, let's come up with a really hard problem to do. Yeah, they're going to throw the kitchen sink at it. So.
Is that going to take a lot of paper?
Not that bad. It's really just a chain rule problem. I mean, now that you just know the derivative of cosecant hyperbolic, and now you got a chain inside of it, it's not that nasty. It could be worse. All right, ready, set, go. Greist, unless you already have the answer for it, try it out too. What are you reading? I know it's a book, Aaron. What class is it for? Oh, for fun. Gotcha. It's a book. It's a book. That might be the most condescending thing you've ever said to me. It's a book. Thank you. I've never seen one of those before. Where I come from, we just had letters, flashcards.
Oh, Minnesota, you know. So.
I'm from South Dakota. It's more likely South Dakota than Minnesota. If you're done, compare it to somebody around you. See what you got. I'll have a volunteer come up and do it again. Sam. Volunteer to come up. This is your shot to impress. Sam, is that what you were raising your hand for?
Yeah.
Come on up.
Yes.
You get to be internet famous. Okay, now, really honestly, is this really that much harder than what we were doing before? No, it's just you got to learn the new trick of what's the derivative of the sine, cosine, etc. hyperbolic.
Oh, you guys get to see my horrible handwriting again. All right,
I
so
set the bar pretty low on that, Sam. My handwriting's like awful.
have you seen mine? Yeah, you
Sam,
probably
I've been your math
oh,
teacher
wait.
for 2 years. Yes, I've seen your handwriting.
Hey,
Even math handwriting.
Is it better or worse? If they're not boring. Jonathan, I'll give you a stack of Algebra 1 papers, and you look at like their name, and you have no idea like what if any of the letters even are. Like they write a word like Jimmy, and you're like, I can't get a single letter in this right. Go ahead, Sam.
Okay, so
That's bad handwriting. I've never gotten through on very rare what the first letter was.
Aaron, why okay. So we start out. So we start out with the first half.
Tell them to be quiet first, or you'll kick them out.
I hate yelling at people.
No, I'm the one that would have to deal with it anyways.
Why is it not focusing?
That little button up top.
Which one? Which one?
One. Just click it one time.
Okay. So we start out with the sine h, or sine hyperbolic. So we take the derivative of that, which is cosine hyperbolic of the inside, 3x squared plus natural log of x. And then we multiply by the derivative of that, which is 6x plus 1 over x. And then we deal with the second half, which I will do down here because I'm going to run out of room. So that would be minus 2 cosecant of cosine x times cotangent hyperbolic of cosine x. And this would be negative normally, but I've already accounted for the fact that this will give us a negative sine x. So this would still be minus on that side. And that's it. Any questions?
Can you simplify that at all?
Probably, but I'm not really going to.
Okay, real quick, is there anything you can take out of both? No, there's not, because this cosine is inside here, this is inside here. I think it's as good as we get. Any disagreement? Any disagreement on that? No, this is the first thing minus the second.
Yeah, okay.
So that's the derivative of that.
You just wrote it on 2 lines.
Yeah. And let's be honest, it's hard to throw that much onto one line of paper in the standard notebook. So, Sam, nice job. Yes, thank you, Brent. Brent, you should start going to the basketball games. You cheer. I can't tell. I'm a little perturbed too. 3. So we started counting in the second half. See how many times you cheer. 3. All right. We might as well. Let's get the integral rules out of the way. Now, most of these you could probably get.
Oh no.
The integral rules for hyperbolic functions. Well, let's go back. If the derivative of sine is cosine, what's the integral of cosine going to be? We'll say that again. If the derivative of sine hyperbolic is cosine hyperbolic, what's the integral of cosine hyperbolic going to be? Sine hyperbolic, right? A duh question on the hard ones, what's the thing that you forget? Don't forget the plus c. Okay, so then what's the integral of sine hyperbolic going to be? Cosine hyperbolic. Keep it rolling. What about tangent? Hold on. What's the integral of tangent hyperbolic? Okay, well, let's rewrite tan. What's tan equal to? Okay, yep, sine over cosine. Oops, forgot the h. Forgot the h. Okay, now think of what are we going to have to do for that?
It's the L.
Yeah, that's the natural log, because what is this going to be in this case then? Let's stop and think about that for a second. So the tangent doesn't directly have an integral because there's nothing whose derivative is tangent hyperbolic. So then we change the form, we change this definition, sine hyperbolic over cosine hyperbolic. So Ryan's got the right idea. We need to think of this as being something of a natural log. If we have something over natural log, we need to think of this as being the what power? -1, and then this being the derivative, right? So what's the integral of the tangent going to be? The natural log of absolute value of cosine hyperbolic u plus c. Why is that one different than the other ones? Like the rest of them, they rotate back and forth. Why does tangent not do that? Right, none of the derivatives set them. Nobody's derivative is tangent hyperbolic, so we have to go back to the natural log functions for that. What about secant squared hyperbolic? Yep, that's tangent. Stop and check out questions so far. And notice all of them so far have been what? All of them have been positive so far because when the sine, the cosine, the tangent hyperbolic all have those positive derivatives, so the integral is going to be positive. For the rest of them, they're all going to be what? Negative, right on. Let's go for next one. Let's go for cosecant hyperbolic squared. Oops. What's the integral of cosecant squared hyperbolic going to be? Yep.
Wait, is that one underneath it?
Just the next one. What's the integral of secant hyperbolic times tangent hyperbolic? Just the next one. Yep. Secant what? Yeah. Okay, the last one I'll give to you in reverse. Whose integral is going to be the cosecant hyperbolic? What do we have to have under there for its integral to be cosecant? Let me rewrite that. Hold on. What is the integral? What has to be underneath there for its integral to be negative cosecant hyperbolic u plus c? Give me 15 seconds. Think about that. Give me 15 seconds. Volunteer, what would have to be under the integral for its integral to be negative cosecant hyperbolic u plus c? Call. Cosecant hyperbolic, cotangent hyperbolic du. And let me rewrite that. Cosecant hyperbolic u times cotangent hyperbolic u times du. For its integral to be negative cosecant hyperbolic u plus c. Okay, that's the rules. Questions on that before we go to an example? Miller, easy one or hard one first? I don't know. I'm bad at decisions. Let's hard one. All right. Easy. Okay, let's do cosecant hyperbolic of 2x dx. If that's too easy for you, let's do chain rule 1 second. The integral of, let's go cosine hyperbolic 2x times sine hyperbolic squared 2x dx. Ready, set, math. Yeah. Let's take a look at the first one first, then I'll give you some more time to work on the second one. The first one, the only trick to that one is you have to deal with the what? The 2. Okay, so if we set u equal to 2x, then du has to be what? 2. So we need a 2 where? Inside or outside? Outside. Inside. Let me see with the integral. Do we need the 2 inside the integral or outside the integral?
Inside, don't you have 1/2 outside?
So how do we get the 2 inside? Multiply by 1/2 outside. So 1/2 integral 2 cosine hyperbolic of 2x dx. So we've got the cosine hyperbolic. We've got its inside value. We've got the derivative of its inside value. So we can take the integral 1/2. Volunteer, what's the integral of that going to be? Sinh
Basis, cotangent, cos.
plus c. Don't forget, the harder the problem, the easier it is to forget c, which is a silly point to miss on your AP test, but
How do you say the cosecant one?
cosecant, I don't remember. Sinh, cosh, and I don't even remember what tanch. Tanth,
Yeah.
tanth. Christ, do you know? Sinh, cosh. I don't know that one either. It would be a really dark alley. Somebody's going to ask you to give the mathematical abbreviation for tangent hyperbolic. So, okay, next one, take a peek. What kind of problem is this one? Because even though they get hard, we're going back to the same questions we had before. What type of problem is that? It's a chain rule problem, which means what are we really thinking of being our u in that function? Sine hyperbolic, right. So really we have u squared, and we need du to be out here. Okay, the harder question, what's the derivative of that going to be? And it might actually be easier to think of it like this. Remember, this is just the mathematical shorthand.
Why did I do that?
Okay, the honest reason of why they do that is mathematicians are really lazy and they don't like to write these parentheses. So how can we write these parentheses? They just bring it in between.
Wait,
And that's seriously the reason why it's there.
Can't you just be sin hx? It's like u squared.
That, let's spread it that way.
Because then just use.
Okay, we can do it that way. So then u is equal to sine hyperbolic of x.
2x.
Okay,
2x.
2x, thank you. Okay, so then what's the derivative of that?
2.
Okay, so cosine hyperbolic of 2x, then multiply by the derivative of the guts, which would be 2. Okay, what's the only thing we're missing up here then? We got a squared, so it's going to be u squared. Remember, Mary said she wanted to do it with this being u. Okay, so that's u squared. Du, I have that. What am I missing? Missing the 2, so I got to bring a 2 in here. What do I got to multiply by out here? 1/2. So this is going to be equal to 1/2. I'm going to change the order. Sine hyperbolic squared 2x times 2 cosine hyperbolic 2x dx. Making my u substitution then, that becomes the integral of u squared. This would be my du.
Can you wrap it up?
Yep. So this is my u squared. This is my du. So as we said at the start, this is a chain rule problem. The hard part of the new part is it does have that sine hyperbolic, cosine hyperbolic in it. But really all we have to have is those derivative rules to be able to deal with that. So it's nothing different than really dealing with the sine or cosine problem, except they have different rules. The kind of weird at this point, it just becomes what? Well, when we take the integral of something squared, it's going to be something over. Right, so there we go. 1/2 u cubed over 3. Don't forget the silly point, but you got to put what? Plus c. Now, we dealt with that one in the warm-up today that had it switch the endpoints to u. If they do have the final answer with u, don't forget if there are endpoints, you got to switch them. How do we get back to x, though? Substitute in, multiply through to get 1/6. U was equal to sine hyperbolic of 2x, whole thing cubed plus c, or you could bring that cubed in there. Either answer. To be honest with you, I think the multiple choice would probably have that answer, the second one, but somebody said, did I make a mistake? Yeah, it's ugly, but is it really that much harder? No, not that much harder. Just ugly.
Could we have done it if we kept u as the sine squared?
Yep, because what's the derivative of the squared going to be? 2 base, 1 less power derivative of the base. No questions? Everybody totally gets that?
Yeah.
Mr. King was sitting in here right now, and I told him everybody totally got that. I wouldn't be lying to him. I have one nodding head, and the rest of you looking over Mr. King scared. Yes? No? Okay, got it. Well, just throwing it out there since he's here.
I believe it's because my brain is starting to swim. I really respect all that that you guys put in this class. I hope you guys appreciate your amazing math teacher, because few folks get teachers.
Okay, so now that that's done, let's talk about what's on your test. Usually they don't come to calculus because they don't know what we're talking about. So, well,
Every time we said something, I was like,
yeah, I did look over it a couple times. He's just like hyperbolic, huh? Wonder what that means.
He should have been here when you're explaining what hyperbolic is.
I don't think that would have much mattered. I don't think you realize what % of the American population gets to 2 semesters of calculus.
I didn't even know that there's a different form of grade.
There's actually, Bryce, did I loan that geometry book to you?
No, you
I was
didn't.
looking for it the other day.
I've got this ask.
Well, no, it's all of so you spend about the first 3 weeks just remembering all the rules from Euclidean geometry, because here's the bad news about geometry, and you guys actually already mentioned this when you were doing the ACT warm-ups, that you learn a lot about geometry, and then you really don't do anything with that ever again except the trig part. So like proofs, like parallel line proofs, then they magically appear on the ACT, and you haven't done them since you're in geometry, and some of you took geometry in like 4th grade, so it kind of actually puts you at a disadvantage. But Ryan, you actually learn all of the non-Euclidean geometries, and this one is actually called hyperbolic geometry because hyperbolas end up being parallel lines in hyperbolic geometry. There are 6, and if you know more than, if this is 15 years ago, I'm gonna be honest with you, I got rid of that class as soon as possible because I hated the prof. Bad news in college. If you have a prof who writes his own book, here's the really bad news for you. If you don't get the prof, you also don't get the what? The book, because guess who wrote the book? Your prof. Yeah, so he charged $87 for his notes for the class. They were awful. This guy oftentimes would just say, well, I don't really know how to do this one, so we're just gonna skip it. And then you're like, so do we still have to do it for the homework? He's like, of course you do. But you wrote the book. Like, it's one thing if I can't do these problems, I didn't write this book. if you read the book, at some point you should have been able to do the problem, preferably when you're teaching the class. So somebody I loaned that to, but I don't remember who that is. But yes, there's 6 different geometries besides Euclidean. What's that? Might have been Vlad. Let's talk.
So
I have to think about that.
Pay to take notes.
What's that?
So I made you pay to take notes.
No, you got all the notes. So like you didn't ever have to take notes because they were all in this packet, which was ridiculous because it was just copies. But of course, he's a prof. He can charge whatever he wants. So yeah, he charged $87 for it. And
Wait, he like made textbooks?
so going further into this, which I was trying to avoid ever getting off topic today, but
Oh, I'm sorry.
so at the start of it, he said, oh, there's no good geometry books out there, so I wrote my own. Which really, when he said he wrote his own, what he did is the last time he taught the class, he just made copies of all his notes and then put them in a packet and then charged you $87 for them. So it wasn't really a book. It was like if I just took all of my notes and made copies of them, which if I just showed you this, or if I gave this to basically anybody on the planet not in this class or higher and showed them this, like this is worthless to them. Like, oh, Kosh. Wonder what a Kosh is. And that's what he did for the class. So that was our textbook. So the bad news is, guess what the notes were? Exactly verbatim what he said in class. So every day, you know how some teachers teach by PowerPoint and they read the PowerPoint to you like you're not capable of reading it yourself and like provide no other insight to it, which really should be illegal because I can read PowerPoints at home on my own. If you're not going to at least provide some insight on it, why didn't I just stay home and read this myself? Because I could have done it in like 5 minutes instead of 90. But that was okay, just blow your mind with parallel lines. And then like, he's just like, I don't know how to do that proof. So you got yeah, it's on your test too. So you're going to figure it out eventually.
How many kids are in the class?
Like 9. There's not very many people in the higher level math classes. And here's the bad news. They're the same 9 people. So you get it's like IB, but even smaller. So you get really annoyed with the other people in your class. And there's one kid that really loved that prof and like sucked up to him all the time. And he would just say things like, that's okay, Dr. Nielsen. You just figure it out whenever you can.
That sounds like he's being sarcastic.
No, he was sucking up. Like
That's being sarcastic.
yeah,
That's
they.
okay. You just figured that out.
Some college is a little bit different than high school because like you can talk about religion, and this prof like openly talked about his religion like all the time, and like how wonderful it was and the wonderful things he'd done with it. And this guy like had just converted, I swear, to suck up to him even more. And so like they'd have their 45-minute talks in like 50-minute class, and some days they talk 45 minutes about some mission trip they were going to go on. And I have no idea what this song is about. Please work one question on this. And yeah, so you think I get off topic? College profs do too. Okay, so let's talk what's on your test. First one, average value. Remember, it's everything since we started. It is a 90-minute test. There's multiple choice. There's free response.
Thursdays or Thursdays?
Just show up 15 minutes early. You know, I'm always here early.
Wait, can
No,
we
we
get
can't.
Yeah, I know. No, I'm not. I can't do that to my kids. I can't wake them up earlier. Yeah, but then they get sick, and then I end up missing whole days instead of 15 minutes. So it's not a good trade-off for you guys either, because you might not believe this, but there aren't a lot of subs that can teach Calc too. So, who?
Oh my
yeah.
gosh.
Who did I have?
He was like
Stuff, like, trying to
criticizing what I
like
got on my
explain
test.
some integral stuff.
Who was it?
He stops.
Mr. Bear?
He had like orange pants or something.
That doesn't help.
I don't remember his name, but he, like, tried to
Don't give
do
me the
stuff.
sub with orange pants. They're not gonna know what I'm
He
talking
was
about.
young. He was young.
Oh, I remember who. Yeah, yeah, because he came up the next day and was like trying to suck up to me because he's becoming a math teacher. Like, I'm gonna hire. Here's the deal, but you're gonna get the job. You don't have to suck up. You're a math teacher. You don't have to suck up.
Hey, he's gonna teach you.
Well, if he wants to, it's kind of his. I mean, to be honest with you, if Ellie applied,
Why didn't you tell him that?
hey, who needs college, right? Right.
Yeah, why don't we each of us take on an algebra class?
So I like teaching Algebra 1. Those kids are fun. Like,
So you want us to teach calc? What do you want us to
2.
grade calc?
I don't.
I'm being honest with you, Ellie. I'd have a lot more free time at night if I didn't have to work these problems at home. So I don't have to.
You'll have more experience before I get here.
Yeah, I know. So
I still mess with
true.
math.
Yes, I'll even have more experience next year. Okay, let's remind you, average value, which is why we find the average value over an interval. Don't forget, those are classic multiple choice problems, so that's why we are talking about them. We have our motion of the particle problems, the marginal cost problems, the integral of the derivative of cost.
No, when you write the questions for marginal cost on the test,
Yep.
can you like outline like this is the set of costs you want to find?
I'm not gonna lie to you, I don't write them, I just take them off old AP tests.
But like they don't make sense because they
I
don't
don't
know what is the
understand, just like
marginal
the
cost
total
because it doesn't
cost,
say
I
marginal cost.
Can we
Could we
finish
go
do
through
this so
one?
we can do one?
What's that? Yeah, we'll do, let me go through everything that's on the test first. Particle problems, marginal cost problems, displacement problems.
Oh, I like this.
Which are not that bad. Josh, we need to talk at the end of class today.
Yeah.
I asked for forewarning. You didn't give me forewarning.
Is
I,
she a-
you never warned me. You were wanting to come to the shacking up ceremony.
why did you break up
That's a
with
real
her?
conversation Beckman and I had. He's like, if you're not gonna get
Why
ready-
did you break up with her?
So, very true. Okay, don't forget, we talked about use substitution, which is really the way of saying it's the opposite of the chain rule. Opposite of chain rule.
Yeah.
I will still insist with you, and going through my notes from when I took Calc 2, my prof told me and was willing to show that every single problem that a use substitution was used on, there was an algebraic way to do it without a use substitution. However, in the sake of time, sometimes use substitution is just so much faster that we use it for efficiency, not because we have to.
So will we be required to use?
There is a problem on there that's significantly easier with a use substitution than without a use substitution. I will look for one. Those are hard to generate off the top of my head. Like a marginal cost one I can generate in no time. But one that has to have a use sub.
I just don't want one.
I'm sorry. And again, every problem, and again, in college, like profs really can cover whatever they feel like. So like if they don't finish Calc 2, nobody cares because nobody tells profs what to do. But you have to take the AP test. My prof would sometimes, and my notes will show you, spend an entire class period to go through one homework problem just to prove that you didn't ever have to use the use substitution, because she swore that you didn't have to use the use substitution, that you didn't actually have to learn that. Because just like Thomas is asking right now, when I took Calc 2, there was a guy that insisted it was so much easier, and she was out to prove that you didn't have to do that, that it was simply a laziness of the mind. And well, here's the deal. Don't use a use substitution on your test is what she's really telling you. So
Think smarter, no?
well, that's where you analyze your audience and say, this person hates use substitutions. If I use it on the test, I'm probably not going to do that well. So some people, however, didn't get that memo. So use substitution is the opposite of the chain rule. Don't forget, you also need to set that in terms of du. You need du is something you need.
Oh, like you can't be DS.
Well, remember, if like you're taking, like if it's 3x squared plus 1 to the 5 fourths power, you need the derivative of that inside part to be able to take that power rule integral. What else? There's lots of that. What else? We don't have to cover that one. Natural logs. Don't forget about the absolute value when you're doing that. Don't forget, the only time you wouldn't need an absolute value is if the function is positive for all values of x, like x squared plus 1 is an example of that. It's always positive, so you don't have to worry about that. And then, of course, we have the inverse. I actually don't think they will. I'm not 1,000% sure about that.
I'd rather not even have to think about it.
I'm meeting with her tomorrow after school, and I'll ask that one again, but I don't think so. No, I go up there. Hi, please give me all your knowledge and drive down to DCC too. No, I drive up there.
What sections is it? 5?
It's 5.4 through 5.9, plus the particle motion and stuff like that. The particle motion just isn't in this book because that's like an AP thing that they love, but this is not an AP book, so they spend a minimal amount of time on it.
You said 5-4?
Ask Storch to remind me during TA next period. I will. 5.4 to 5.9 is the sections in your book that it is. Oh, excluding 5.6. 5.6 isn't on the AP test. The inverse trig integration and then the hyperbolic ones. Hyperbolics is revisited in chapter 9 because then we learned some really fun integrals that can be found via the definitions.
What do we do with inverse trig?
What's that? Just integrals, integral rules.
Oh,
That's what we did last time. Sine to the -1, arc sine, tangent to the -1, arctan. No, but that's really nitpicking and nothing that I want your brain to have to worry. I believe there's actually only sine inverse, cosine inverse, tangent inverse. I did not see any arc sine, etc. I did not see any, or I don't recall seeing any. How about that?
You don't have to know. It's like randomly arc cosine.
Oh, yeah.
So, Mr. Beck,
In the text, you said we were going to do sine -1.
that's already said.
I said sine h -1, which we will revisit later in chapter H or chapter 8. In this book, there are actually 3 chapters we're gonna have to take little parts of, but they're small parts. Again, I visited with her specifically for the topic of are we gonna finish on time? I'm getting a little nervous that we're not going to have as much review time as I was hoping, but that's obviously a problem better than what you had last year, where you just said, hey, do 2 chapters tomorrow. The test is tomorrow. Good luck. We're on a fine pace. You have to remember when you look at the next chapters, they're not like 9 sections like this one is. They're 3 sections, 4 sections, 5 sections. So they go significantly. This is the longest chapter in the entire book. And plus, I'm hoping, since we've kind of talked about differential fields a few times, that it's not a new topic. It's a topic we're picking up on. But the chapters are much shorter from here on out. I mean, integrals are probably the largest part that you have to learn because, again, you have to learn all those derivative rules for the integrals. So I'm not worried about nervous pace. I mean, here's the bottom line. If we get to the point, like if we get 4 snow days in a row or something, I'll just make videos of a chapter and you'll do it over spring break. So, I mean, like I said at the start of the year, the goal is, and we will put you in a position where you're going to get a 4 or 5 on the AP test. You can watch videos in Mexico. They have the internet in Mexico. I've been there.
Can you watch?
They even have it in like Costa Rica. Even China has the internet. Call.
So what's our calculator test?
There's some problems that are no calculator. There are some problems that are calculator.
What's the essay question?
No essay question.
Yay.
Yep.
I know you said this earlier, but you know how we get an AB sub-score for our
Yep.
tests?
Yep.
Okay. So what?
You working for the FBI on the side?
No, my answers.
Okay, gotcha.
But our AB sub-score for the
Yep.
BC test, is that like, can you send that score?
It automatically goes. You can't not send the AB sub-score. You just send those.
So like if we got 5 on the AB sub-score, 4 on the BC test, we can still get credit for the AB sub-score. Like colleges I'm applying to get different credit for BC.
They should look at so again, if you look at the college and you look at their website, there should be somewhere that's an AP IB transfer guide.
Yeah.
And they should say like what you have to get on the AB test to get credit for blah, blah, blah class.
Yeah.
If they only take the AB score, they should look at the AB sub-score. So the good news is I've heard, and this is Hutch to confirm this, that if your AB sub-score is higher than it was your AB score last year, the only one they send is that higher score. And Mrs. Hutch could confirm or deny that, but put it this way, Monahan, if you don't score higher on the AB this year than some of you did last year, it's actually not possible. Because even if you say had a stroke on the first problem, you get the same score you got last year. Those of you that got a 1 last year, you can't do lower. So all you have to do is pay for it, actually. Even if you don't show up for the test, you still get a 1. So.
Wait, okay, well, the college is still mad.
What's that?
Will college be mad for that?
I did hear you. Will the college be mad at it?
Got a 1.
Okay, and let's go back to the first day of class and let's talk about that. So remember, I said the first day of class this year, like you need a 4 or 5, because if you have a 4.8 GPA and you've got an A in calc, but you've got a 1 on the AP test, you're going to start to wonder, like, what kind of school did you go to? Like,
So again, in calc, we got 1 on the AB test.
You should be able to put like
They
a
don't
comment.
use
about
Comment?
yeah.
Well,
There is a section, if you feel like
Yeah,
your
oh, yeah.
application does not meet your qualifications, explain why.
But to be honest with you, I don't want you to have to go to that section. I want you to have a score that represents doing as well as your grades are saying. So that already had to do that. And Thomas, I hope you know in my soul, I feel infinitely guilty for that because I
Credit